In class, I'll be teaching you 9.1, exploring combinations of functions. There are many interesting functions that can be made by combining two or more simple functions. By adding, subtracting, multiplying, or dividing these simple functions, more complex ones can be created. One way a combined function can be formed is by adding f of x and g of x to result in a new function h of x. This new function will be the combined properties of both original functions. For example, this y equals 3 and y equals 5, if I add them both together, they'll result in a new function, h of x, which will be a combination of both of them. To add two functions together, they must have the same domain, and if given the coordinates of x values, must be the same in order to add them. Which pretty much means if one is restricted, I can't add these two because the domains are no longer the same. It's impossible. This combination can be done using two ways, table of values or algebraically. To start, I'll show you this one, which is simple. I don't have to use either of these ways. It's just f of x plus g of x, which is 3 plus 5, which is equal to 7. H of x is equal to 7, which is this new function right here. Now, I'll show you how to use the table of values or how to do it algebraically using this more complex version. You see here there's a parabola and linear function, so I'll show you how to use a table to solve this. First, you write down the x values, which is -2, -1, 0, 1, and 2. Then you write down the values of the parabola. X squared is 4, 2, 0, 1, 4. And that's not a 2, that's a 1, my bad. Then the values of the linear, which is -2, -1, 0, 1, and 2. And then you want to find out what happens when f plus g of x, which you pretty much get by adding these two functions. So 4 plus minus 2 is 2, 1 minus 1 is 0, 0 plus 0 is 0, 1 plus 1 is 2, and 4 plus 2 is 6. Now you got the coordinates of the new function, which is pretty much this, and x. So now you write them down. You'll see their combination of both graphs. You see, when it's -2, it's 2, when it's 1 is 0, 1 is 0 is 0, 1 is 1 is 2, 1 is 2, it's 6. This new graph right here, this new parabola, is the combined function, since it takes both functions and adds them together and puts their properties together to create this one. Algebraically is just as easy. All you have to do is realize that f plus g of x is equal to adding the two functions together, which is x squared plus x, which when factored out is x multiplied by x plus 1, and then you could use 2 as an example. It's 2 plus 1, and it's equal to 2 multiplied by 3, and this is equal to 6, which is the new coordinate of your new function right here. So that's how you solve the combination of functions using algebra and the table of values.
Hello class, my name is Isaiah and I'll be going over 9.2. So, when two functions f of x and g of x are combined to form the function f plus g of x, the new function is called the sum of f and g. For any given value of x, the value of the function is represented by f of x plus g of x. The graph of f plus g can be obtained by adding the corresponding y coordinates. Similarly, the difference of the two functions f minus g is f minus g of x, which is equal to f of x minus g of x. The graph of f minus g can be obtained by subtracting the y coordinate from f from the y coordinate of g for every pair of corresponding values. So, for the first example, we want to determine f plus g. So basically what you have to do here is find the matching x coordinate. So in this case it would be -3 over here and -3 here. And what you want to do is add or subtract the y coordinate here. So in this case it would be 3 plus -9, which is -6. So we found the y coordinate here. For the next one, -1, it would be 2 plus 3, which is 5. And then you want to keep doing this. Here would be 1 plus 1, which is 2. Right here would be 0 plus 3, which is 3. And for the last one, it would be 1 plus 9, which is 10. Moving on to the next question. Determine f minus g of 7 when f of x is equal to x squared minus 5 and g of x is equal to 8 over x minus 3. So basically, you could just think of this as f of 7 minus g of 7. So what you want to do here is just plug in the 7 for the x coordinates. 7 squared would be 49 minus 5, that's 44. and 8 over 7 minus 3, 8 over 4, minus, and 8 over 4 is 2, so that would be 44 minus 2, which is equal to 42. That's right. Okay, so B. Which value of x is the function f minus g of 7 is undefined? In this case, it would be 3, because the function g of x, if you were to plug in 3 right here, it would be 3 minus 3, which is 0, and 8 over 0 is undefined. And yeah, that's... what is the domain of f minus g of 7? It would be x belongs to a set of real numbers, such that x cannot equal to 3, since it's undefined. And moving on to the next one. Let f of x equal to x and g of x equal to x squared. Sketch both f of x and g of x from x values from -2 to all the way to positive 2 in that range. So I already did this part here. Just how to plug in the values. Simple as that. And now be sketch f plus g from -2 all the way to positive 2. So basically what you want to do here is you want to just add the y coordinates like you did in example 1. So -2 plus 4, that's positive 2. -1 plus 1 is 0. 0 plus 0, that's 0. 1 plus 1 is 2, and 2 plus 4 is 6. And you have the y coordinates here, and you could just graph it, but I won't do it here for time's sake. And you just, and see, sketch f minus g. Yeah, you basically just do the same thing except you subtract. And yeah, that's it.
Functions 9.3, combining two functions product. We're gonna skip through that and we're gonna read the three main points. Algebraically, f multiplied to the g is defined as the product of f and g is equals to f of x multiplied by g of x. The domain of f multiplied to g is the intersection of domains f and g. If f of x is equal to 0, or g of x is equal to 0, then the product of f and g is also equal to 0. If f of x is positive or negative 1, then the product of f and g is equal to positive or negative g of x. Similarly, if g of x is positive or negative 1, then the product of f and g is equals to positive or negative x, f of x. Now, we are given these sets of functions. To multiply sets of functions, x values must be similar and multiply the y values to find the product of f and g. Now, this and this are similar. This and this are similar. Now, that will give us 2, 0, -6, 4, 13 times 6, 78. 78. Sorry about that. 78. Now, for this one, you just multiply them together. So, -5 multiplied by x is equals to -5x.
Lesson 9.4, Exploring Quotients of Functions. The logistic function is often used to represent the quotient of two functions graphically and algebraically and to determine the characteristics of the quotient. The function h of x equals f of x divided by g of x is the quotient of two functions. F of x will represent the constant function and g of x will represent the exponential function. The logistic function is an example of a quotient function. In function notation, we can express this as f divided by g times x equals f of x divided by g of x. So these are the key things that you need to know, and I'll jump right into the example. For the following pairs of function, calculate f divided by g times x. So this is what we have. We're going to use this, and it is f divided by g times x equals f of x divided by g of x. So our f of x is 176. We take 176 divided by our g of x, which is 11x. And this gives us 16 over x. Okay, let's graph the f of x and g of x on Desmos, because this is what that question asked. Graph each pair of the functions f of x and g of x and include the new f divided by g times x. Okay, I'm going to use Desmos for this, and I'll be back. And lastly, we need to state the domain for f divided by g times x, which is domain equals x belongs to a set of real numbers in which that x cannot be equal to 0. X cannot be equal to 0. That's it. Those are 3 steps. Done. That's lesson 9.4.